Welcome to Brain Vision.
In the first part of this question, we're going to show that the energy level differences become smaller and smaller as we go to higher and higher energy levels, which is when n goes to a very large number. So we know that in general, the energy level for the hydrogen atom is given as negative 13.6 eV divided by n squared. For an energy that is just 1 above it, this will be n plus 1, just negative 10.6 eV divided by n plus 1 square. Now we can find the difference in the energy by just taking the n plus 1 minus n. To give us 1 over n square minus 1 over n plus 1 square. Now to simplify this fraction a little bit, over here, we can combine them together. So we get n plus 1 square minus n square. We open up the brackets a bit. This will become n squared plus 2n plus 1 minus away n square. We get 2n plus 1 over n square times n plus 1 square. So therefore the expression over here becomes 13.6 eV times 2n plus 1 over n square times n plus 1 square. Now as n goes to a very large number like infinity, 2n plus 1, right, the 1 over here, the magnitude will be much smaller as compared to the value of n. Therefore 2n plus 1 is just approximately just 2n, and the denominator, we can do the same thing, right? N plus 1 would just be equal approximately just n. So the denominator and everything, the fraction can be approximated to be just 13.6 eV times 2n over n to the power of 4. Therefore, by cancelling out the power of n, we should get 2 over n to the power 3. So delta E, the energy difference, is proportional to 1 over n to the power of 3 as n becomes very large. And therefore, when n goes to a very large number, delta E becomes very small. Now on the other hand, if we were to consider radii instead, so we know that the radii for a general orbital, right, general quantum number n for hydrogen is given as r naught, a constant multiplied by n squared. Sorry, not r naught, this is r1, which is the first, right, the ground state orbital radii multiplied by n squared. So as n goes larger, we can do the same thing as the energy, right, expression that we did earlier. Just consider n plus 1. The difference in the radii, just Rn plus 1 minus Rn. To be R1 times 2n plus 1. And we see that delta R is actually proportional to n. activate, just approximate this to be r1 times 2n when n is very large. So delta r is proportional to n. Therefore, when n increases to a very large number, the difference in orbital radii will be larger. So they will not get closer to each other, but rather they will get further apart when n increases.